Now, I said PCIe Express is the de facto standard, and that is true. That's what we're using today. But they are going to mention, and some motherboards still have, for backwards compatibility, the old school PCI. It still stands for Peripheral Component Interconnect, but that's it. It was introduced in '95. It connects the CPU, memory, and peripheral all together. It supports bus mastering, IRQ, plug and play. We're not going to talk about all that, and that is not test worthy. What we just learned is the PCI was the original version for expansion slots and cards to be incorporated onto a motherboard. It is replaced by PCI Express. Excuse me. First commercial version was 2.0, and then they revised it over and over again until we came out with the PCIe Express that we use today. Now let's start talking about two different important parts of this. It used to be that computers used parallel communication. Parallel communication is up here in the left-hand corner is an example of parallel. So it had to have so many wires, them little traces and buses, so many wires to push through so much information, the speed. The faster that component needed, the more wires that physically had to be located on the motherboard. So think about it. If we used to stick with the old parallel PCI connection, every time we made graphics cards, sound cards, things go faster, we would have to add more and more wires and more wires. Well, we're not doing that. We're getting away from making things larger. We're shrinking technology. So the whole idea of parallel communication is going on the wayside, and we're using something called serial communication. And we'll get into both of them in just a second. You can see parallel was either 32 or 64 bits. So another way to think of this is if you're standing there and I got to get information over to you, and the way I'm going to do that is I'm going to get 32 balls and I'm going to chuck them all at you at one time. 32, 32, 32. That's how parallel used to talk. That is not really efficient. It sounds like it is, but it's not, because I'm stuck to 32 bits, and that's the most I can throw at you. On the other term, which we'll talk about in a second, serial communication is like a fire hose. When we say PCIe by one, just think by one is one lane. It's just like a lane out on a highway. It has a northbound and southbound. It's a highway. And when I turn on that fire hose over that lane, I can push as much information I can through one northbound and one southbound communication. So I'm not having to deal with just 32 bits at a time. I can have them follow each other back to back in a stream and get as much communication as I can over that. If I need larger communication pathways, well, then I create 4 highways by 4. If I need larger, by 8, by 16 highways, all serial communication flowing through northbound and southbound for each highway. So that's where we come into serial communication. So the PCIe, which is our standard today, as we can see down here in this colorful picture, our PCIe slots, different sizes, obviously are going to be different speeds. Now, the hard ones to dictate between are like the by 4 and by 1. They look about the same physical length. They're slightly larger, the by 4s and 1s. And you're going to have to look on the motherboard, on the small print, or in your documentation to figure out exactly what speed PCIe ports you have. But PCIe uses that serial communication with point-to-point links between any input and output device. It replaced PCI already. It's not designed to. It did. It is the new standard. It is a serial communication for dedicated links or lanes to all components. So what I just explained to you, they're pretty much spelling out here. Taking a look at this again on how this works, because it is very important. Your serial communication uses lanes, sets of wire pairs. Here's 1 highway, here's 2, here's 3, here's 4. I don't know why that switched. So this is your by 4 lane. 4 highways. Not too hard so far, right? Each component supports a specific number of lanes. Now we're using serial communication so we can push bits streaming one behind the other through each lane, and in this case, 4 lanes at a time. So the throughput becomes extremely more fast and more suitable for the large graphics cards and quicker devices we need to connect to today. Now, power features of PCI. Different versions. Now, PCIe, this is really what you want to look at is the versions. So the first version, PCIe, came out, one of the newer versions, when it first came out, only could support 500 megabits transfer rate. 500 megabits. Why isn't he saying megabytes? Well, let's just get this out of the way since we're early in this course. Megabits, capital M, small b, means that information is traveling. When you're downloading something from the internet, it's always megabits, gigabits. When you are storing a movie on a hard drive, that is static. That size of the data is gigabytes or megabytes, capital M, capital B. Gigabytes, capital G, capital B. So when information is static, it's the capital B afterwards. Megabyte, gigabyte. That's what I save to my hard drive. When information is going from one device to the other or traveling across the motherboard or anything, when it's in transit, it is small b, megabit, gigabits. All right, now that we got that out of the way. So PCI 2 was only 500 megabits per second. PCI 3 came out, and this is where it really took off. 1 gigabyte per second. 1 gigabyte per second. Should say gigabits, but we get it. 1 gigabyte per second means double the throughput. Version 4, 2 gigabytes per second. Version 5, 4. So they're showing you per lane. This isn't the total amount of throughput it can support. It tells you per lane, every highway, how much it can support on these different versions. So you can see right here, again, just looking at the different sizes and designs of your PCIe slots. This is much better. You got your by 1, you got your by 16. Again, by 1 would just be something easy like a network adapter. By 16 is usually going to be held to support your graphics cards. This is where your crazy high-end graphics cards go. And then right on the same board, they have a backwards compatible 2 PCI slots. This is, again, in case you're using an old piece of equipment that you must have and it's supported PCI, this motherboard can still support both types of buses.